All right, in this section, we're going to learn to solve a quadratic equation by factoring. So if this is our equation here, 2x squared minus 5x equals 12. Step 1, we want to move everything to the left. Okay, we want to have everything on the left-hand side and set this equal to 0. So we're going to have to move this over, which means we're going to have to subtract 12 from both sides. And we end up with 2x squared minus 5x minus 12 equals 0. Step 2, we're going to factor like we did in the last section. So when we go through that, we're going to first start with 2x times x. That gets us that 2x squared. Then we list all the factors of negative 12 and we try them to see which one gives us a negative 5x in the middle. If you need some help on that, make sure we review the videos from 4.2. This is what works. 2x plus 3 times x minus 4. Now steps 3 and 4, we're going to set these equal to 0, both of them. So we do 2x plus 3 equals 0, x minus 4 equals 0. And then we solve for x. Move your 3 over, you get 2x equals negative 3 when you subtract 3 from both sides. Divide by 2, and on this side we get negative 3 halves. Over here, add 4 to both sides, we get x equals 4. Now you want to check those. To check that, take the negative 3 halves, plug it back into the original equation everywhere you see an x. And you should end up with 12 on the left-hand side. 12 equals 12 is true, and it works. Take that positive 4, plug it back in everywhere you see an x. You're going to end up with 12 equals 12 is true. So your solution set would be written like this. Negative 3 halves and a positive 4. Let's look at another one. On this one, you want to get everything on the left. So we are going to move the 20x over, subtract 20x, so this is what we get. Now it's time to factor. We take out the greatest common factor, which is 5x. We did not have a common factor on the last one we looked at, so we kind of skipped over this step. I should have mentioned it though. Take out a 5x, which means you're dividing both of these by 5x. Okay. And you end up with 5x on the outside. This reduces to x, this reduces to negative 4. So now we have 5x times x minus 4 equals 0. Set both of those equal to 0. Here when you divide by 5, x is equal to 0. Here when you add 4 to both sides, x is equal to 4. So we have two solutions, 0 and 4. And I do need to mention this while I'm thinking about it. The most solutions you can have is your highest power. So if your highest power is 2, 2 is the most you can have. You can have 2 or less. If your highest power is 4, you could have 4 or less. Now here's what this looks like on a graph. Our solutions were 0 and 4. If we were to graph this equation, we'd end up with a parabola. And 0 is where it crosses the x-intercept, and 4 is where it crosses the x-intercept. Let's look at another one. If we had x squared plus 4 equals 8x minus 12. First thing we want to do is get everything on one side. So I'm going to subtract 8x, that goes here, add 12, and 12 plus 4 is 16. Then we factor. This factors into x minus 4 times x minus 4. We don't have anything we can take out, so we do two sets of parentheses. Set both of those equal to 0, and you get x equals 4. Now we have two of them, so we don't have to list it twice. They're the same, so we can just leave it as a 4. And here's what that would look like in a graph. That means there's only one x-intercept here because it happens at the vertex. Look at another one. We have x plus 7 times x plus 5 equals negative 20. We have some work to do. First thing we want to do is FOIL this. We get x squared minus 2x minus 35 equals negative 20. Then we want to add 20 to both sides. That gives us x squared minus 2x minus 15 equals 0. Factor this. There's nothing in common, so we start with our two sets of parentheses. We get x plus 3, x minus 5 when we factor it. Set those equal to 0. X plus 3 equals 0. When we subtract 3 from both sides, we get x equals negative 3. X minus 5 equals 0. When we add 5 to both sides, we get x equals 5. So these two would be our solutions. And here's what it would look like on a graph. If we graph this parabola, notice our x-intercept's at negative 3 and our x-intercept is at positive 5.